This is Tom, and I'll be presenting our CS project proposal on behalf of our team. So here's some introduction and some background information. American Sign Language, ASL, is a predominant form of communication for deaf communities and many others, which is used by over 500,000 people in the United States alone. Many language models are extremely complex. In particular, character comprehension is our main goal. We aim to use a MNIST-like data, as well as large amounts of data on Kaggle, to analyze and recognize ASL. While countless technologies developments have greatly allowed people with disabilities to live their lives to the fullest, there continues to be difficulties in communicating effectively. Allowing computers to understand and comprehend ASL visually would enable communication to not only be much more efficient, but could enhance understanding between ASL and non-ASL individuals. To allow our model to focus on accuracy instead of attempting to classify every aspect of the ASL language, we aim to focus on the 26 Latin letters as well as punctuations and digits. We aim to focus on two separate areas: solo character comprehension and general sequence translation. We will be using transformer architecture, a well-suited model that has been specifically applied to similar language translation problems. For our data, we're using an MNIST dataset that contains 785 columns with one label column representing the letter, hand signs, and 784 columns representing pixel data. There are 26 different labels from 0 to 25 to represent A to Z. All the values in other 784 columns contain values from 1 to 255 representing RGB values. The dataset is 66.2 megabytes and contains 71,000 rows. Here's a link to the dataset. Our goal is to perform machine learning techniques to achieve high accuracy in predicting the label. Some accuracy measurements we can do is accuracy, measure the percentage of hand signs classified correctly, precision, measuring the model's ability to correctly classify hand signs to minimize false positives. Recall measures the model's ability to capture all instances of hand signs to reduce false negatives, and F1 score. Here's a potential timeline that we would like to implement. We would divide up the work by each members and work every week. Here's some references. Thank you for listening to our presentation.